11th class, Mathematical Method 2. My name is Borokinni Adebowale Samuel, and I'm pleased to put you through this course. In this course, we are going to learn three main topics. We are going to learn ordinary differential equation, Fourier integral, Laplace transform. Of course, in this course, we are expected to understand and make use of various methods for solving mathematical problems. So, for this topic, which we want to consider as ordinary differential equation, you will learn what a differential equation is. You will be able to distinguish between an ordinary differential equation and a partial differential equation. And finally, you will be able to define and identify the order and degree of an ordinary differential equation. Yes, what is an ordinary differential equation? Well, an ordinary differential equation is an equation that contains derivatives. What do I mean by that? So we need to understand what the derivative of functions are. Let's start by defining the derivative of a function. Consider this equation y equals f of x. This is simply written in this form, and it implies that we are saying y is a function of x. We call this the independent variable. And y is called the dependent variable. Also, the independent variable is also otherwise called the input variable. While the dependent variable can also be called the output variable. What is establishing the relationship between the dependent variable and the independent variable is the equal sign. So, when we couple y with the equal sign and the function of x, we have what is called an equation. Thus, an equation establishes the relationship between the dependent variable and the independent variable. In calculus, we consider a form of this form, say y equals y against x, or x against y. If you have a straight line of this form, we can determine the slope of this line, or the gradient of the line. Usually the gradient or slope measures how steep the line is relative to the horizontal axis. So for us to determine the gradient, all you just need to do is to determine the change in the horizontal axis, also determine the change in the y-axis, and say that the slope, as it were, is change in y over change in x. But For more advanced curves, you'll notice that this formula cannot be used to compute the slope of curves. So what do? All you just need to do is to ensure that the change in x is as small as possible, even almost negligible, so that you can obtain the slope of such a curve. That is, we are saying that for more advanced cases, the slope of a curve will simply be change in y over change in x for very small change in x, for very small change in x. And for that case, this definition that we have here is denoted as dy dx. Mathematically, this is written as dy dx as a notation is limit as change in x gets very small of delta y over delta x. This is simply the definition for the derivative of a function y with respect to x. We can also have higher order derivative, meaning that if you have differentiated a function for the first time by obtaining dy dx, you can differentiate what you have obtained before. Maybe you have obtained dy dx. You can still differentiate that dy dx with respect to x to obtain what is called second derivative. So second derivative will be written as the square y over the x squared, which will mean that you are differentiating dy dx, that is d dx of what you have obtained earlier of dy dx. You can also obtain nth order derivative, which for higher order derivative you can obtain, that is, you can obtain this form by saying the ny over the xn, which is obtained as the derivative of what you have differentiated earlier, which will mean differentiating the nth minus 1 derivative of the function y. Higher order derivative is very important because that will enable us to determine the order of an ordinary differential equation. Now, having understood from the concept of calculus what an equation is, and also what a differential the derivative of a function is, then we can define a differential equation. What then is a differential equation? Differential equation. A differential equation is an equation that contains derivatives. Of unknown function. That is a differential equation. However, the differential equation may contain both ordinary derivative, which we will refer to as total derivative, or partial derivative. So a differential equation therefore can be classified into two. We are going to denote differential equation by this letter DE, differential equation. So a differential equation can be classified into an ordinary differential equation, and a partial differential equation. Partial differential equation. What is an ordinary differential equation? Simply put, it's a differential equation in which the dependent variable is a function of just one variable. So in that case, we can only have total derivatives. While for partial differential equation, it is an equation, a differential equation precisely, that contains partial derivative. So in this case, we are going to have the dependent variable for the partial differential equation. The dependent variable is now a function of more than one variable. The variables can be 2 in number, 3 or more. Now, our focus is on ordinary differential equation. Now, we are going to talk about the order and degree of an ordinary differential equation. Order and degree of an ordinary differential equation. What is an order of an ordinary differential equation? Simply put, it is the order of the highest derivative contained in the differential equation. What do I mean by that? As I've mentioned earlier, we have a form like this called dy dx. This is called first order derivative. Now suppose I have the n, the xn of y. This will be referred to as nth order derivative. So when I define an order of an ordinary differential equation, then I'm saying that all you need to look at in the equation is to look at the highest derivative contained in the ordinary differential equation. And the highest derivative will dictate the order of the ordinary differential equation. Let's take an example. Consider this equation of the form d square y dx squared plus 2y dy dx minus 5x is equal to 0. What is the order of this differential equation? Precisely, ordinary differential equation. The order, to determine that, look at the derivatives this equation contains. We have two derivatives. This is one of the derivatives, and this is another derivative. This is a second order derivative because we have differentiated y twice. Why this is a first order derivative where we have differentiated y just once. So the order of this ordinary differential equation we said is the order of the highest derivative the equation contains. And as you can see, 2 is higher than 1. So the order of this differential equation or ordinary differential equation is called second order. And we refer to the differential equation as second order derivative. What about degree? Degree, simply put, is the power to which the highest derivative contained in the differential equation is raised after rationalization. What do I mean? Take for instance, as I've mentioned, we have a derivative of this form, the y dx. Let's consider another one, the square y, the x squared. And let's consider another, take for instance, the nth order, the n y, the xn. This is a derivative. This is another derivative. And this is another derivative. The power of this derivative is simply raised to the power of 1. And of course, a number raised to the power of 1, you get that number. So this is simply mean the y dx still raised to the power of 1, and we still get the y dx. This also is raised to the power of 1 because it's a derivative. And when we say the square y, the x squared, all to the power of 1, we still get the same as the square y, the x squared. And of course, this is also raised to the power of 1 too, because it's a derivative. The ny, the xn, all to the power of 1, we get the same thing. But now, suppose I raise this to 2. I raise this to 2. I raise this to 2. Then the power of this first derivative will be 2. And you can't have the y, the x raised to the power of 2 still getting the y dx. No. So this is raised to the power of 2. And this becomes a degree. This also becomes a degree because we have the square y, the x squared raised to the power of 2, which is also a degree. And likewise this. But in an ordinary differential equation, to determine the degree, all you just need to do is to look at the highest derivative the equation contains and then check the power to which it is raised. That power is known as the degree of the ordinary differential equation. As an example, this is what we mean. Consider this. I have the y, the x raised to the power of 3 plus 2y, the square y, the x squared raised to the power of 2 plus 4x is equal to sine x. And you are told to determine the degree of this differential equation. How do you do that? First, what is the highest order derivative? For this, you will see that this is just the y dx raised to the power of 3. So this is a first derivative, but the power of that first derivative is 3. So let's see it. First derivative power 3. This is second derivative. Y is differentiated twice, but power 2. So we have second derivative power 2. Now the question is, what will be the degree? Is it 3? Is it 2? Definition says that you need to check the power of the highest derivative after rationalization. So as you can see, this is first, second derivative. The highest derivative definitely is second order. So what will now be the power of that derivative? It is 2. So simply put, the degree of this differential equation is of power 2. So we say that degree of the ODE is referred to as ordinary differential equation, is 2. And to interpret it, we say this is what? An ordinary differential equation of what? Second order and degree 2. Degree 2. So far, we have been able to define a differential equation. And to do that, we defined the derivative of a function for us to understand what a differential equation would look like. We consider the case of a function of just one variable, since our focus is on ordinary differential equation. And next, we define differential equation as equation containing derivatives. And that may include containing total derivative or containing partial derivatives. And we classify differential equation into 2, as ordinary differential equation and partial differential equation. And we went ahead to define the order and degree of an ordinary differential equation, where we mentioned that the order, simply put, is the order of the highest derivative contained in the ordinary differential equation. And finally, we define the degree of an ordinary differential equation as the power to which the highest derivative in the equation is raised after rationalization. Now try this. What is the order and degree of a differential equation whose highest derivative is 2 and the power of the highest derivative is 2 after rationalization? Also, what is the degree of a differential equation whose highest derivative is 2 and the power of the highest derivative is 1/3, while the derivative of the others are of even whole numbers? Thank you for listening.